Okay, what's rather annoying is that my keyboard broke because I spilled water on my keyboard. So now my Z key doesn't work. So if I want to undo, I either have to rebind it, which is I'm too lazy to right now, or I have to plug in an external keyboard. So if I want to undo, I'm gonna have to stretch my arm and like hit a couple of like keystrokes on like a Dell mechanical keyboard. And I'm using a laptop right now, so it's kind of really annoying. But anyway, that is not the point of this video. The point of this video is to present a graphical intuition of limits. So I'm going to make a graph. I'm going to draw. Okay. I'm going to try and sketch a thing. Alright, and we're going to calculate some limits today, graphically, not analytically. So how about, let me ask the first question. How about the limit as x approaches? This graph, by the way, is going to be y equals f of x. So I want to find the limit as x approaches 1 of f of x. Alright, so how to evaluate limits graphically? You follow the function from the left-hand side, you follow the function from the right-hand side, you ignore the actual value of the function at c. So in this case, c is 1. So I know that f of 1 here is defined to be 3. There's a hole and it kind of jumps up to 3 and goes right back down if we're going from left to right here. But when you're evaluating limits, you don't actually care about that actual value. You want to find the value that's getting closer and closer to 1, but not actually 1. So you ignore this, and you just follow the left-hand limit, and you come to a conclusion. You follow the right-hand limit, come to a conclusion. And then if they're the same, then you say, yes, the limit exists, and it is the point that both these limits converge on. If they're not the same, then the limit does not exist. So for 1, let's see, we follow the left-hand limit, it goes closer and closer to 1 until it hits 1, and it's not actually 1 there, but we're going to say that the left-hand limit is 1, and the right-hand limit also converges to 1. So, in fact, this entire limit, since the left-hand limit and the right-hand limit are the same, the limit as x approaches 1 of f of x is 1. So that wasn't too bad. What about limit as x approaches 2 of f of x? Well, the left-hand limit, let's see, we go up and up and up and up and we hit 3. Left-hand limit is 3. And the right-hand limit is, we go down here, follow it up to 5. And notice that it's not defined at 5, it's defined at 3, but we don't actually care where it's defined. And we see that the left-hand limit is not equal to the right-hand limit. In other words, there's a jump like this, which is common in piecewise defined functions. So they're not the same, so the limit does not exist, which is D and E is shorthand. So let's do limit as x approaches 4 of f of x. Well, the left-hand limit you see, boop, 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 it approaches 3. So left-hand limit is 3. The right-hand limit also approaches 3. So the total limit equals 3 because the left-hand limit is equal to the right-hand limit. So yeah, graphically, it's not very hard to evaluate limits. Oh, I'm not gonna write this down, but this is a trick one. What's the limit as x approaches 7? So if you approach from the left here, this is 7. As you approach from the left, it equals -1. But there's nothing to approach from on the right-hand side. There's no function. So do we just say it's -1? Well, actually, no. Because the right-hand limit doesn't even exist, the whole thing doesn't even exist. You can say that the limit from the left-hand side, from the negative side, equals -1. But for the whole limit, you can't just say that it exists because the right-hand side, there's no right-hand side to work with. So that's a trig question. Alright, and then next video I'm going to do 2 examples, maybe 3, of just evaluating limits analytically, and then we'll get to infinity limits, absolute value limits, and the like.